Okay, this is chapter 3, section 5. This is the last section of chapter 3. Okay, so the slope of a non-vertical line is the ratio of change in the y direction to the change in the x direction. In other words, it's y2 minus y1 over x2 minus x1. So if we have 2 points on a graph, for example, this one and this one, the slope is just their change in the y direction divided by their change in the x direction. And a lot of the times you'll see me write it as rise over run. It's how much did it rise, how much did it change vertically, over how much it changed horizontally, okay? So the m being y2 minus y1, that's just the slope, and then you divide by the change in the x coordinates. Okay, so a positive slope is one that moves, that rises as we move to the right. So see how if we're moving along this graph to the right, it's increasing. Same thing with a negative slope. As we move to the right, it's going down. So it's moving further, it's falling. For a zero slope, okay, that would be a strictly horizontal line, okay? Y would equal a number. And for undefined, that would be a vertical line. So x would equal a number. Now, why is it 0 and why is it undefined? Well, for a zero slope, we're not rising at all. We're staying completely in the run category. So rise equals 0. And if the rise is 0, then the run can be anything. So our answer is going to be 0. Now, if our run is 0, our rise can be anything, but we're still dividing by 0, and that's undefined. So for any vertical line, x equals anything, your run is always going to be 0. The slope is always going to be undefined. Okay, so there is a theorem. It's called the slope of parallel lines theorem. And it's in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. So guys, let's take a look at this blue and this red line. So if they're parallel, which we see that they are because they have the two arrowheads, then their slopes have to be the same. So the slope of the blue line, m1, is going to be the same as the slope of the red line, m2. Okay? So if the slope of the blue, is, well, I see that it's a negative slope. Let's say it's -2. Then slope red must also be equal to -2. All right, so then we've also got a theorem about the slope of perpendicular lines. So in a coordinate plane, if two non-vertical lines are perpendicular, if and only if the product of their slopes is -1, or they're opposite reciprocals of each other. So horizontal lines are perpendicular to vertical lines. Well, let's take a look at this image. So we've got the slope of the blue line, and then it's intersected to create a 90-degree angle by the red line, okay, as we see right there. So their slopes, m1 times m2, will give us -1 since they are perpendicular. So if we took the slope of the blue line, I see that it is negative. It's going down as we move to the right, and it's pretty steep. So we'll say the slope of the blue is -3. The slope of the red line has to be a value that when we multiply by -3 is going to give us -1. And that value is 1/3. And there's a little trick that I have that I want to show you guys, okay? And my trick is, we'll label this Mr. J's trick. My trick is, if it was a positive value, you're changing it to a negative. And if it's negative, you're changing it into a positive. Okay? And then from there, then you just flip it. And this is called opposite reciprocal. So for example, since we had the slope of the blue line to be -3, right? We started with -3, we changed it to a positive value, so it became 3, and then we flipped it. So instead of 3/1, it became 1/3. Because remember, any whole number written as a fraction is that number divided by 1. Okay, so example 1, we're going to complete some of these statements with sometimes, always, or never. So the slope of a vertical line is blank 0. It's never 0. The slope of a vertical line is always undefined. The run will be 0, but the actual slope is undefined. The slope of a horizontal line is always 0. The slope of a line that rises to the right is positive, always. And the slope of a line that falls to the right is always negative. Example 2. Find the slope of the line through the 2 points named. All right, so whenever we have a problem where it's asking us to find the slope, we want to label each as x1, y1, and x2 and y2. So we're going to label this x1, this y1, this x2, and this y2. And remember, our slope formula is m equals y2 minus y1 over x2 minus x1. And in this case, we've got y2, so let's take m equals 5 minus 4 over x2, which is negative 4, minus a negative 3, x1. This is going to become 5 minus 4 is just 1 over negative 4 minus negative 3 is negative 4 plus 3, so that's going to be negative 1. So this is just negative 1. x1, y1, x2, y2. So m equals negative 2 minus negative 3 divided by negative 1 minus 6. Negative 2 minus negative 3 is negative 2 plus 3, which is going to give us a positive 1 on the top. And negative 1 minus 6 on the bottom is just going to be negative 7. So our answer is negative 1 over 7. And for C, we're going to label it x1, y1, x2, y2. And m is going to be equal to, we have negative 4 minus negative 4 over negative 3 minus 8. Now I see on the top we're going to get 0 over, and then on the bottom we're going to get negative 11. This is equal to 0. Remember, any number, if 0 is divided by any number, that's still 0. And this is going to be a horizontal line. And I could have noticed that right from the get-go because I noticed we have negative 4 as our y1 and negative 4 as our y2. So there's no change in the rise direction. It's not rising or falling at all. So therefore, it has to be a horizontal line. Okay. And lastly, let's do negative 6, negative 2, negative 6, and 9. So this will be our x1, this will be our y1, this will be our x2, and this will be our y2. So m is equal to y2, which is 9, minus negative 1, which is our y1. And then we have negative 6 minus negative 6. So this is going to be equal to, oh, I'm sorry, I put negative 1. It should be minus negative 2. Okay, so 9 minus negative 2 is going to give us 11 on the top, because it's 9 plus 2. And negative 6 plus 6 is going to give us 0. Now, this is not 0. This is undefined. Which means that it has to be a vertical line. Okay? All right, complete the table for R parallel to S and R perpendicular to T. So remember, if R is parallel to S, then their slope must be the same, right? And if it's perpendicular, then it must be the opposite reciprocal. So for S parallel to R, this is just going to be negative 1/2 because the slope has to be the same. Now, for T, this one's a little bit different. Now we have to, I see that R is negative. We're going to change it from negative to a positive, and then we're going to flip it. So it's going to be positive 2. Okay? Now if T was 1/6, R would be the opposite inverse. That would be negative 6, and s would also be negative 6. If s is 1 over 5, r is also going to be 1 over 5, and then t is just going to be negative 5. If s was negative 4, r would be negative 4, and t would be 1 over 4. Now, if t was a, okay, r is going to be negative 1 over a. Remember, we changed the sign and then we flip it. And then s is going to be the same, so negative 1 over a. If t was 3b over 4, in order to find if it's parallel, it's just going to be 3b over 4. Oh, I'm sorry. Nope. R and t are perpendicular, so it has to be negative 4 over 3b. And then s has to be the same thing. Okay, if r was parallel to s and r is a horizontal line, what is the slope of s? The slope of s must be 0. Why? Because remember, horizontal lines always have a slope of 0. So if r and s are both parallel, then they have the same slope. And then if k and n are both perpendicular, and n has a slope of 0, what is the slope of k? So if n has a slope of 0, we're looking for the slope of k. We know that they're perpendicular. Well, the opposite inverse of 0 is going to be 1 over 0, which is undefined. So that's the slope of k. Now, another way you could have looked at it, if we know that the slope is 0, what kind of line is that? That's a horizontal line, okay? And remember, vertical lines are perpendicular to horizontal lines. You could have recognized that k had to be a vertical line. And in that case, you would have known that the slope had to be undefined. Okay, slope-intercept form of a line. So the slope-intercept form of a line is just y equals mx plus b, where m is our slope and b is our y-intercept. So m is how much we're rising and falling, and over how much we're running, and b is our y-intercept. It's where it intersects the y-axis. So let's go ahead and do A, B, and C, and we're going to plot them on our graph on the next one. Okay, so we'll do A in green. We'll do B in blue. Oops. And then we'll do C in red. So let's take the green one first. We've got 2x minus 3y equals 6. Most of us are probably like, that doesn't look anything like the slope-intercept form. So what we have to do is we have to change it into slope-intercept form. Let's do that over here on the left side. So this is 2x minus 3y equals 6. We can subtract 2x from both sides. We're going to get negative 3y equals negative 2x plus 6. Now remember, the reason I subtracted 2x was because we're trying to get y alone, because that's what slope-intercept form is. It has the y alone on the left side. Now we want to divide by negative 3, divide by negative 3. These will cancel. We'll get y equals negative 2x divided by negative 3 is going to give us 2 over 3x. And then 6 divided by negative 3 is going to give us minus 2. So this is our new equation in slope-intercept form. Now, the slope of this line is now 2 over 3, and the y-intercept is now negative 2. Let's go ahead and plot that. That's all we need to know in order to plot it. Okay, let's do the blue one. So the blue is already in slope-intercept form, so that's awesome. So all we have to do is recognize what the slope is and what that y-intercept is. So the slope in this case is negative 1 over 4, and the y-intercept is positive 2. Last line is just y equals negative 3. So I don't see x in here at all, right? So in other words, the slope must be 0. And our y-intercept must be negative 3. Let's check it out. So our y-intercept was -2. That's down here. And our slope was +2, 3. So move up 2 and then over 3. This is our next point. And we can also move down 2 and to the left 3. This is our next point. We just draw a line that is straight through these 3 dots. That's as good as it's gonna get, people. I know, pretty bad. Okay, and then we can move on to the next one. So let's locate +2. Let's put a point there. That's where it intersects the y-intercept. And -1/4. So if we're moving up, that's positive, so we have to move to the left. 4. 1, 2, 3, 4. Right here. And then same thing in the other direction. So if we move down in the y direction, then we have to move to the right in the x direction. 1, 2, 3, 4. It's right here. Can draw to the best of our abilities a line through all these. That was a little bit better than the last one. Okay. And then so let's go to -3. And remember, our slope is 0, so we're just going to draw a horizontal line. Perfect. That's what your graph should look like. Okay. Example 6. Write an equation of a parallel line. Write an equation of the line passing through the point -1, 1 that is parallel to the line with the equation y equals 2x minus 3. So we are going to use our slope-intercept form. That's y equals mx plus b. And what we're going to do is we're going to plug in. So we have our coordinates -1, 1, which means that x equals -1, y equals 1 at that point. And we know that our slope has to be 2. Because what we're looking for is we don't know what b is, right? We know that our slope has to be 2. But we don't know b right now, okay? So let's plug everything in. We've got y, which should be 1, equals m, which is 2, times x, which is -1, plus b. So this becomes 1 equals -2 plus b. We can add 2 to both sides. We would get 3 equals b. So our equation has to be y equals m, which we know has to be 2, x plus 3. That is the equation of the line that goes through the point -1, 1 and is parallel with the equation y equals 2x minus 3. Okay. Write an equation of the line J passing through the point 2, 3 that is perpendicular to the line K with the equation 2x plus y equals 2. Well, our first things first, we want to change this into slope-intercept form. So all we have to do is subtract 2x from both sides, so we get y equals -2x plus 2. This is our slope of this line, but remember, we want it to be perpendicular. So the slope of our line should be +1/2. And then we've got the point 2, 3. So x is going to be equal to 2, y is going to be equal to 3, and we're going to solve our own equation, okay, for our line J. So y is going to be equal to mx plus b. We just plug everything in. Y, which is 3, equals m, which is 1/2, times x, which is 2, plus b. 1/2 times 2 becomes 1, so we get 3 equals 1 plus b. We subtract 1 from both sides, and we're going to get 2 equals b. Now that we have b, we can write our own equation. So y is going to be equal to, remember, the slope is 1/2 x plus 2. Number 8, guys, we are not doing number 8. Go ahead and cross it out. We're not doing those kinds of problems. And then you've got your homework. Good luck.